Hi, in this part of the tutorial I'm going to go over a case where the landmark detection fails in one of the images. So for this tutorial I'm going to use the images distributed with ATRA under the example2 directory. So let me change directory to that example2. Here we see we have 3 volumes. So to run art, the first task is to create an image list file as before. So and then ATRA minus I image list minus V for verbose and minus output, um, foo as an example. Or let's just not use the output prefix. So as you can see, the program starts running and it will finish in a few seconds. Okay, it took 12 seconds to finish. Now let me just check the Orion images, or Orion ppm files, to see if everything is okay. So I can tell you that these images are from a 87-year-old individual, taken over a period of a year and a half. So here I can see that the landmarks on images 2 and 3 look fine. However, for image 1, I get this, which doesn't make sense. So from this I can tell that the ACPC detection failed on image 1. So I need to now specify the ACPC and the VSPS landmarks for image 1 manually and rerun the program. So now I'm going to show you how this is done. For this purpose, you will need the AFNI program. So running, the reason I like to use AFNI is that AFNI and ART define the XYZ coordinates similarly. So the troublesome image was image 1. So I bring it up on AFNI. So now under AFNI, I will go to define data mode, miscellaneous, and switch on the voxel coordinates. Once you switch on the voxel coordinates, the XYZ coordinates reported here are in units of voxels. So, and that's what we like. Now I need to determine the location of ACPC and the VSPS automatically. So usually what I do is go and look at the sagittal and coronal and axial images all together. Here's the AC. So these locations do not have to be exact. As long as you're in the ballpark, that's fine. Usually what I do, I change the gap to 1 voxel so I can see more precisely where the crosshairs are. So this is my AC. I read the coordinates now, 122, 139, and 67, 122, 139, and 67 for AC. I record it somewhere. So, and then I will locate the PC. So This is the PC. Looks like I have to go a little bit in the posterior direction. There it is. So the coordinates for PC are over here, 98, 129, and 67. And finally, I find the coordinates of the vertex of the superior pontine sulcus, which is right here. Looks like I should go a little bit to the side. So there it is. And I record the coordinates of this point, VSPS, as shown here, 108, 109, 121, 68. 109, 121, and 68. So now I can close AFNI, and over here I will go and create a new file. I'm going to call it v1.lm for landmark, and inside this file I'm going to put those numbers. For AC it was 122, 139, 67. For PC it was 98, 129, 67, and for VSPS it was 109, 121, and 68. And this is the order that these landmarks have to be specified: AC, PC, and VSPS XYZ. Okay, so I save this file. Alright, now I have for image 1, I have a file called v1.landmarks, which manually specify the landmarks for this file. Now I'm going to go in my image list file and add a line right after image 1 and specify my landmark file, where the program can find the manually detected landmarks. Say if also I had a landmark file for image 3, I would just call it v3.lm and specify it right after image 3. So the program knows where to look for these landmarks file, if any. If it's right after you specify the image itself. In this case, we only have one image for which we had to manually specify the landmark, and this is image 1. So I specify the landmark file right after that, and now I'm going to go back and run the program again. If I can find it. Okay, ATRA minus I image list minus V for verbose. There we go. So now you can see that again it knows that the number of images to be registered is 3, and then for volume 1 it has found the landmarks file. So it's going to use, it's not going to attempt to find those 3 landmarks automatically. It's going to use what we specified manually. So now it's finished. This time it took 26 seconds. And now let's go back and look at the Orion landmarks again. Okay, now we can see that for all 3 images, the landmarks have been correctly specified, correctly detected. Well, for image 2 and 3, we knew that already, but here we see it for image 1. So we can see those landmarks, the 8 landmarks. Okay, so I can close GIMP right here. So in the next video, I'm going to show you how I will check for the accuracy of the registration algorithm.